Well, welcome Year 10 to Lesson 19 of our flipped classroom tutorials. Alright, well as said, we are starting a new topic which is trigonometry, the study of triangles. And today's lesson we're going to look at something you're familiar with called trig ratios, or sine, cos and tan. Okay, so what is a trigonometric ratio? Sine, cos and tan simply represent the ratio of two sides in a triangle, the length of two sides in a triangle, dependent on what given angle is in the question. Number two, we use these ratios to help us find unknown sides and angles within different triangles. Number three, a trig ratio is written as a fraction, and when we go back to what we did with ratios earlier in the year, we know that the ratio 3 to 4 can be written as a fraction as 3 over 4. Okay, so we've already done this in class, but here are two right-angled triangles above us. I told you that we're only going to be looking at right-angled triangles this year, and I also told you that the symbol or pronominal now used for missing degrees are usually letters from the Greek alphabet. And so the angle pronominal that you can see in the two triangles above is called theta. This one is a very common one that we will always use. Alright, so we already know how to name the different sides of right-angled triangles depending on the angle that we are given. The first one is the hypotenuse. This is always the longest side of a right-angled triangle. If another way to think of it, it will always be on the opposite side of the right angle. Number two is the opposite side. Now the opposite side is always the side opposite the angle given. So I'll bring it back up again. We can see that this side of the right angle triangle is the opposite side because it's opposite theta, the angle that we are given. In the other one, the opposite side can move because in this triangle, the angle has moved and so its opposite side will also move. But always remember that the opposite side is the one opposite the angle. The last one is the adjacent side of a triangle. Adjacent means next to, and this is the side that is always sitting next to the angle, or, as somebody said, the side in between the right angle and the angle that is missing. Okay. So, below are your three final trigonometric ratios. These you need to remember, simply put into your head like cement. The first one is sine. Now, sine of theta will always equal a fraction. We said it would be a trigonometric ratio, and these are expressed as fractions. And sine theta is a fraction with the opposite side over the hypotenuse side. Cos theta will always be the adjacent side, or the length of that side, over the length of the hypotenuse. Tan of theta will be the length of the opposite side over the length of the adjacent side. So these we're going to write in our books. Write them also down now if you can, and these need to be imprinted into your memories. So how do we use this? Okay, well here's a right angle triangle where I've given a missing angle or theta, but in this case I've given you values or the lengths of each side of this triangle. So the hypotenuse has a length of 5, the opposite side has a length of 3, and the adjacent side has a length of 4. So how do we find sine of theta, cos of theta, and tan of theta using this triangle? Well, look below. We've already said that sine of theta is the length of the opposite side over the length of the hypotenuse side. In this example, it would be 3 over 5. Cos of theta will be the length of the adjacent side over the length of the hypotenuse, which will in this case be 4 over 5. And tan of theta will be the length of the opposite side over the length of the adjacent side, and in this case 3 over 4. Now this is all great, but why, or really how, do we use this knowledge? This is what we're going to look at in today's video. Number 1, how to find what a missing angle, or theta, is equal to. So one reason we use trigonometric ratios is to find the value of missing angles. So let's start with the same triangle I gave before, with the same values. The hypotenuse has a value of 5, the opposite side has a value of 3, and the adjacent has a value of 4. Now if I would like to find sine of theta, we know, well, I should go back a little bit, this question is asking us to find what is the actual value of theta. So this is the first part of why we would use our trig ratios to find a missing angle. And in this case, once again, the missing angle here is theta, and we want to find what it is equal to. Okay, so if we're given all 3 values on each side, we can choose any of the trigonometric ratios. In this case, I've chosen to use sine of theta to solve this question. Now your first step of working would need to be sine of theta equals what side over what side? And we would know from our memories that sine of theta is the opposite side over the hypotenuse. Second step, put your values in, just like we did before. So sine of theta is actually equal to 3 over 5. We simply substituted the values for the opposite side and the hypotenuse side into this equation. Now, this might be new to you, but think of this like any equation that we've done before. Our main aim is to find exactly what theta is equal to. Not what sine theta is equal to, but what theta is equal to. So in this case, we want to have theta all by itself on the left-hand side of the equation, and to do so, we need to remove sine. To remove sine, we simply do the opposite, which is a calculation called the inverse of sine. I'll show you how to do this on your calculator. But to remove sine, we need to do the inverse of sine. You'll find this on the shift function of your sine button on your calculator. So we've always said, to remove sine, we do the inverse of sine. This will remove sine from the left-hand side of the equation. But what we do to one side, we must always do to the other. So, on your calculator, you would need to write 3 over 5, shift sine. Once you did, we've removed sine from the left-hand side, and we're simply left with theta. If you've taken the inverse sine of 3 over 5, we are now left with 36.87. Therefore, theta is equal to 36.87 degrees. Alright, well, we're going to do a lot more of these in class when I see you this week. And the next lesson, and what we'll finish off this term with, is how to find missing sides in right-angled triangles using our trig ratios. Alright, Year 10, well, I hope you've had a nice weekend. I look forward to seeing you this week.